Welcome to Brain Vision.
In this problem, we are given that a 300-gram football is kicked with velocity 25 meters per second and as shown in the diagram. Now we are given the coefficient of restitution between the ball and the ground, and we want to calculate the magnitude and direction of the final velocity of the ball after it has rebounded. So firstly, applying some kinematics, the parabolic trajectory of the football as shown in the diagram, and due to the symmetrical properties of the problem, the velocity at B, Vb, must equal to the initial velocity Va. There's no friction due to the air. So at point B, the initial velocity of the ball is 25 meters per second. And angle phi, as labeled in the diagram, is also 30 degrees. Now we can go ahead and apply the conservation of linear momentum. So if we apply the conservation of linear momentum, now there are no impulsive forces acting on the football along the x-axis, and so the linear momentum of the football is conserved along the x-axis. So if we take the left direction as positive, the initial velocity of the football in the x direction, m vbx, before it collides with the ground, is equal to its momentum after it collides with the ground, m v prime b, and that's the x component. Now we know the initial values for the football. So that's the mass, which is 0.3 kg. So we're going into SI units. And its x component of its velocity is 25 times the cosine of 30 degrees. And this is equal to 0.3 times the x component of its final velocity after it rebounds, v prime b x. So since we have only one unknown, we can rearrange this equation and find the x component of the ball's velocity after it rebounds. And this is 21.65 meters per second. And that's positive, so that's to the left. Now, that was applying the conservation of momentum. We can now apply the coefficient of restitution. And we have an expression for this. So if we take the positive y direction to be our positive axis, we get that E in the y direction is equal to 0 minus the final velocity of the ball in the y direction. Remember, the ground is not in motion, over the initial velocity of the ball in the y direction, vby, and the ground is initially also at rest, so that's minus 0. Now we're given this coefficient of restitution to be 0.4. This is equal to minus v prime b in the y direction divided by the initial velocity of the ball in the y direction, which is minus 25 sine 30 degrees, since the ball is moving downwards and we've chosen up as positive. So if we rearrange this equation, we can find that the final y component of the ball's velocity, vby, or v prime by, is equal to 5 meters per second upwards. So hence we have the x and y component of the ball's final velocity. And so if we resolve these two components, the final velocity of the ball v prime b, in its magnitude at least, is the square root of its x component plus its y component each squared. And so that's the square root of 21.65 squared plus 5 squared. And so the magnitude of the final velocity of the ball is 22.2 meters per second. So now that we have the magnitude, we need the final direction. So the direction theta is equal to the arctan of the ball's final y component over the final x component of its velocity. And so that's the arctan of 5 over 21.65. And so the ball's final direction, theta, is 13 degrees.